Hello, and welcome to today's instance of the SIG Cluster Lifecycle meeting, where we're discussing kubeadm, self-hosting, upgrades, and HA. So today, Tim's going to kick us off talking about his proposal for kubelet checkpointing.
So there is an issue as well as a document that I have been working on and talking about with both Lucas and Yuju. I think everyone's in violent agreement with one another on both the approach and the initial stages. I think the ambiguity or the conflict arises around the next stages after potentially the 1.8 launch of what are the next things to checkpoint. And I know Aaron has opinions and thoughts on that, and I'm sure he probably has some statements he wants to make.
Yeah, I guess my position right now is like, I know the freeze is coming up and we want to get some checkpointing in, and just doing pods right now does seem reasonable to me to like at least start moving this forward. My biggest concern is if we're just blanketly leaving out that other objects that a pod relies on are completely undiscussed, that just either the design won't support it or it's just something that we're pretending like we're never going to do, and that worries me. So if we leave it out of the proposal, I get it, like to try and like at least move the needle forward. I just have serious concerns about this kind of pattern in the past has led to, oh, well, it wasn't in the proposal and the way that we designed it means that we can't do this, so we're just never going to do it. And that will really hurt if that's the end result.
I don't think there's anything that precludes us from moving forwards. There is some conflict around secrets, but I'm not going to partake in that argument, right? I'll let other people partake in it because I don't have strong opinions on it. The config maps, I think, is non-controversial, and everyone agrees to that. So I think the only thing that is quote-unquote controversial in some respects is regarding secrets. So I think we have enough quorum here to potentially have that discussion. So
I was going to ask real quick, is anything network related never going to be included in this? Like network policy, plugin resources that networking plugins need, services, endpoints? Like, is the assumption here that these checkpointed pods use host networking always?
I think that's actually a pretty good point. I think one day, something like kuproxy or something, it might be nice for a node to come back up with an existing state of service routes, but I mean, that's like a really big question. I don't know.
Well, I mean, like if the networking plugin doesn't come back up on the node, you're not going to get a pod IP unless you're using host networking. So I want to be really clear that we're saying you must use host networking for this to be useful, unless you have a network provider that is completely independent of nodes themselves. Like,
right. And I mean, that's like the scope and usefulness of this is going to be incredibly small. It's like host networking pods that don't require config maps, that don't require secrets. It's essentially that is the only use case that this is actually solving.
And potentially can't use flex volumes, can't use service accounts, can't use, I was trying to think, there was one more that came up in the discussion that was a host level resource. I'm blanking on it right now. But if that's the scope of this, then this is not a general purpose solution, right? This is a very, very targeted, something that is very specifically targeted at one particular use case, which is this bootstrap pivot. Is that correct?
that for now it is, but the mechanism that we're employing is general. So the potential objects and resources that could be checkpointed are hidden behind the interface, and that the kubelet itself only deals with checkpoints. So the mechanism is generic, but you can hide anything underneath it. Right?
So what about out of process things though? I mean, because like our assumption is we're moving everything out of the kubelet that we possibly can, CNI, et cetera. So like any CNI plugin, any container native storage plugin, et cetera, in a general purpose mechanism, is that going to be calling through the kubelet to get things from the master? Because those will need checkpointing too, right?
So I'm not quite certain what you're implying, because the purpose of it is only to restart the control plane at this point and not to do sort of application level recovery. Like that's explicitly a non-goal. So like,
right. But that's what I meant about general purpose checkpointing. I just wanted to be really clear that this is only for control plane booting. It has nothing to do with application checkpointing. No one should do this who isn't specifically doing it. And we have no plan. Like, that's what I was kind of asking, is like, what's the transition plan? Like, if we're going to say that this is just for this, let's really clearly say we do not have a plan at this point.
It's listed as the non-goals. The non-goals is explicitly stated. And Don was pretty clear about it too, that we will not do this.
Ever.
We will not do application level checkpointing.
Ever. So this is not checkpointing of pods. This is checkpointing of control plane pods. Like, I want to be really clear about that, because that's like, this is the first time we've kind of had this discussion about checkpointing and made the actual statement, we will not do checkpointing for real application workloads, just for this specific control plane self-hosting pivot.
At this time, that's not what this proposal entails. Like, we will not cover that as part of this mechanism, right?
Yeah, Clayton, I think what happened is we convinced Dawn that we could add checkpointing for this specific purpose without having to get into the details of designing a general purpose checkpointing mechanism, which she has basically been pushing back on and putting off for a long time. It's very difficult. And so we need to solve a specific use case here, and we have a very targeted checkpointing implementation that solves that use case, which possibly could be extended to be more generalized, but that is not the intent right now. And that's not something that we would be pushing as SIG Cluster Lifecycle. I think a general purpose checkpointing would be something that sig-node would have to put forward and push.
Yeah. So then I would recommend that we try to not call it checkpointing in a generic sense, so that nobody else is ever confused. It is control plane self-hosting pivot or whatever, like, even in terms of how it's phrased, because I think for anybody else who's familiar with the checkpointing discussion, it would be confusing.
I'm okay with changing vernacular to make people happy. That doesn't bother me at all. But the proposal is linked there too, and feel free to comment on it. It pretty much calls out the use case and scenario, and also explicitly uses the word limited all over the place.
I mean, I guess just this kind of speaks to my concern, that the only use case that this solves for is kubeadm and no one else, or no other uses. And that, I mean, it's just kind of a bummer.
I think there's nothing that prevents it from replacing bootkube over time. And I think we've all agreed to that. It's just a question of the debate, I think, is whether and how secrets are stored, right? That's the one ambiguous point. And we can have that conversation. That's the only piece that would be missing from A to B, right? So it checkpoints pods, config maps. The only other piece that I saw that's missing is secrets. And the only reason why it's not called out, or it's kind of left ambiguous, is that there's contention around it. I think it requires further conversation from those who have strong opinions on the matter, right?
I mean, unfortunately, I don't think, besides Eric, no one else from sig-auth is here, but one of Eric's comments was that we probably have to bring this up in sig-auth if we want to get a good discussion around it. But my understanding is, like, if it's the user's decision to use secrets or not, I don't see how this is contentious at all. And it's ultimately your CRDs or anything is going to end up on disk, and I just can't get past that in my mind of, like, either you're putting it on disk, or the CRD is being put on disk, or the secret is being put on disk. The contention is locking down the secret in the API or the secret in transport. It's not once it's on the node whether it's being stored on disk, because no matter what we do in any of these cases, it's ending up on disk. I just can't get past that in my mind. I don't know where the actual contention is there.
So I think the the question would be from a general, like sig-auth owns, at least to some degree, the general security posture of the cluster. It would be ensuring that when that pod is moved off that node, those secrets go away and stay gone, because essentially you're basically just giving a bunch of nodes root access to the cluster. And so you're making that choice to not have a strong security posture in the first place, which should be an opt-in choice. The moment you do that, though, making sure that you clean it up very strongly afterwards, I think is the biggest part of the concern. Because even if it's opt-in, you're still, like, in a document that we would write about how to write a secure cluster, we would probably have to say, don't use this mechanism unless you limit it to a set of nodes that don't run other workloads. Right?
I don't see how that's fundamentally different from you saying, bring up master nodes with these assets already on disk. If that node is compromised, or that you want to add masters, or you want to repurpose a node, it's the same story. You better clean up all of those assets that are on disk. I think it's actually an easier story to do garbage collection based on checkpointing than it is to document, hey, you better be sure to go wipe the disk of that master node if you want to repurpose it.
I mean, in the sense of today, the security, like if you set up a zone security model where you have masters and nodes, then you have a set of machines that can have that secret. It's about making sure that if someone makes the choice to use this mechanism and they're using it on more than master nodes, that it's really clear that they're doing so. And if they're just using it on master nodes, this mechanism is usually positioned as something that's better than setting up master nodes and managing them through other config. The parallels should be drawn out. That, I think, is addresses most of the general security posture concern. I just, like, that would be like the point of, you're putting secrets on disk, you're right, the secrets would be there already. As long as it's clear in the proposal how to prevent those secrets from being left, as well as controlling where they go, then that's probably the bulk of the challenge there.
Yeah, I mean, I would agree with that. Like, so in our case, we're only actually deploying the checkpointer to master nodes, and then it checkpoint, like the pod checkpointer, the out of kubelet checkpointer. It's only checkpointing those secrets to those master nodes anyway. It does garbage collection of the secrets if those pods, for whatever reason, are moved off of the node. So all that, to me, just seems pretty reasonable, or like kind of baseline that we should be doing anyway.
The other thing is like that kind of zoned deployment where you are hosting the Kubernetes control plane inside the cluster, but on a separate set of nodes. I mean, that kind of zoning is important even if you're not self-hosted, because you still don't want arbitrary workloads running on the master nodes.
Yeah, I mean, that is probably going to be a much more formal requirement or formal recommendation going forward. Like, it's kind of weak right now because many people don't even, like, we don't even have limits on what pods can do. So it's kind of a moot argument. As those become defaults, or we try to put those in default security postures for deployments, that'll become much more reasonable.
And to be fair, there's like so many things that you can escalate to root at this point in most clusters that get deployed. Like, this is an odd one to be like, we're not going to move this needle forward. I get that, like, we should, do this across the board, but a secret existing on disk feels like a strange one to focus on.
No, I disagree, actually. I mean, from the start, we've not written them to disk. Like, they've never been persisted to disk. They've always hit TempFS. And so this is actually like backtracking on something that we've done from the start with secrets.
Sure, but if the other option here is just saying that you have to put them on disk anyway, like that, like, I get the idea of locking them down in the API being a concern, or them in transport, or maybe even them at rest. But if you're putting them on disk anyway, that, like, once it's already local to that node, that's the part that I'm having a hard time seeing, like, where this new concern comes from.
I think maybe the difference is maybe more in semantics. You are writing certificates to disk right now, and you're not writing secrets to disk. Like, you're not taking a Kubernetes API object and persisting that to disk, which sort of changes the contract people have with that API object. Like, yes, they in practice are the same thing. They're both a certificate, and it's just maybe a question of delivery mechanism. But I think maybe that's what people are hesitant to agree to, is saying, we have this API object called a secret. We're trying to sort of get people to use it in a specific way, and this sort of breaks that contract they have with that.
Yeah, the certificates that the kubelet is using for its own purposes, it has ownership of. It knows the content of those, what those are for, and it is responsible for those. Arbitrary secrets used for arbitrary pods, the kubelet does not know what is in those and should not assume that it can write them to disk.
To make this less of a foot gun, it does seem like a good idea for these control plane secrets to be a CRD instead of a secret. It would be easy if they were just a secret to give people access to them who shouldn't really have access to them. Does that solve your sort of problem with the semantics, Jordan? If it's sort of a new CRD, or not a new CRD, a new resource type that is like a control plane secret.
I'm not sure. So the checkpointing, how does a pod reference a CRD? I guess that's like if you're checkpointing all the resources required to start up a pod, and one of those is going to be a control plane thing, like pods don't reference those today, and so you're kind of adding new semantics onto pods. I'm having a hard time envisioning how that would be expressed.
That's true. Yeah. I think Luke, that was one of Lucas. Do you have more clarity there about how that would work?
Yeah. So it's I think CRDs, the thing here is related to general checkpointing mechanism. It's just something other that we suggested we could do in kubeadm AJ.
This was brought up
it's basically a host path mount instead, but that's I wouldn't say that's relevant to.
Yeah, I was going to say that if you use CRD, it won't be encrypted at rest. But then I was like, well, you're not even really going to benefit from encryption at rest because you're going to be spraying the decryption keys around the cluster anyway, or onto the nodes.
Yeah,
so it's like,
exactly.
So, and like, that kind of got me thinking down this line, which is like, the problem is that we've never really defined what an actual secure Kubernetes deployment looks like in concrete writing. My gut, just based on everything we've discussed and what I know of that, is we would never recommend bootstrapping if you want to build a truly secure cluster. Like at the extreme, right? There's a left end of the spectrum and a right end of the spectrum. On the left end of the spectrum for security, you're going to put etcd on separate machines. You're going to give a credential to the masters. The credential on the masters allows them to access etcd and has decryption keys for secrets or whatever. You don't run a node on the masters straight up, like no chance of control plane confusion. You then have a connection between the masters and the rest of the cluster, and you never correlate those. And how the masters set up is really just a different system. So on that far left example, nothing we're talking about here is really relevant. Like if you want that kind of security, you wouldn't run a cluster set up this way. If you step back from that, anything where you start running things on the same node as the master today, you straight up given up all security. So until we get to the point where we have even the rudimentary out-of-the-box defaults on controls about what can run on the master, right? You run root level processes that can escape their isolation and get access to the secrets. Like nothing about what this proposal is intended to run secure clusters. I mean, like, and I don't want to like make that sound prejudicial. I'm just saying like, you're not actually secure if you follow this mechanism. And so the threat model for this kind of cluster is you're not actually worried about people gaining access to these root level secrets. And that feels kind of harsh. Like I'm not trying to be harsh about it, but that's what I worry about when we go down all the bootstrapping and self-hosting flows is we're basically saying we're getting the benefits of running Kube without putting in place any of the guide rails that says we can actually make this secure. That's okay. It's a little bit of a hard sell to then turn around and say that outside this group, right?
I would agree with you for the most part, but I do think that the like scaffolding to eventually make this a much more like right now I would say this is essentially like trusted, you have a trusted cluster essentially, you have a trusted network more or less. But I think that the scaffolding is there to say you could compartmentalize masters in such a way that no workloads end up there except for very specific workloads, and etcd is on completely different machines, and the API servers are isolated in some way, and that they're only able to access the secrets that they need to access and nothing else is. I don't think that like down the line that's like crazy to think that we could isolate things in that way. Like right now, we're not doing a great job of tightening that up. But
yeah, I mean, it's kind of the vagueness, which is if somebody wants to make progress on their proposal, we're basically saying we don't know enough to how to go do that security. So we don't actually know whether this could be made secure. And I think that's like some of Jordan's comments and some of my comments is with all like putting secrets on disk, moving around without the node isolation, whatever, we really don't know enough to be able to say, like we suspect, but like we're going to go down a path where we're not actually positive that this approach will end up with us being able to graduate it to a secure mechanism. If that's a conscious choice, that's fine. I feel like it should be a conscious statement that we make, that we're saying we're willing to trade security and a security profile and the confidence that we can make it truly secure in the future to get convenience now. And it probably needs to be sold that way too, right? Like I'm not trying to be like harsh about it. I just like this is a tension of usability versus security. We've turned the needle to the left. Are we being honest about it to ourselves in how we approach the proposal and how we'll communicate this to end users?
I'm actually still trying to understand kind of where the proposal falls between a static manifest, which only requires locally available resources, and kind of recreating everything the API server would have provided after a cold start. Are we? It seems like once you try to run pods that you got from the API server after a cold start, you're just kind of opening the door to 1,000 bug reports of, oh, my pod depended on this resource, and PVs weren't checkpointed, and PVCs weren't checkpointed, and config maps weren't checkpointed, and like the network plugin that is supposed to be running that needs its information based on all the services in the cluster, that's not running. And like I have a hard time seeing how doing it generically is going to be able to be done kind of piecemeal. But if the specific goal is to let us start a cluster with static pods and then bring up infrastructure managed pods to kind of replicate that in an HA environment and have the cluster be able to recover from that after a cold start, it seems like we could do things in those static pods that could stand down the static pods as long as the infrastructure managed ones were still available. And then after a cold start, the static pod has an init container that says, is the API service available? Cool, I don't need to run. If not, then I'm going to start back up my static API server. Like, and once you kind of drop down to that level, you're back in the realm of, the kubelet is managing its secrets and certificates, and it knows it's okay to persist them locally with root-only read permission. If the static pod that's running the API server needs its config and its serving certs and things like that, I think it has the freedom to persist those locally with root-only read permission, because at that point you're in application domain and it knows what those secrets are and what the implications of persisting those are. Something that a static pod that could be cognizant of config changes and certificate changes and keep those replicated locally so that it could recover after a cold start seems interesting to me. I didn't know if that had been explored at all.
I mean, that's kind of fundamentally what we do right now with like the external pod checkpointer. It's essentially shuffling static pods around on disk saying, oh, your replacement parent is now running, the replacement API server, so you don't need to run anymore. So remove that static pod, stop running. It could be moved into init containers. It works today. It's just kind of gross because you're trying to determine local state of the kubelet in not very reliable ways. Like we could open up new APIs in the kubelet to make this easier, but I mean, it works. It's just, it would be much nicer if the thing that already knows the local state, the kubelet, is the one making this resolution of, this checkpointed pod should run or not. but that is kind of what we're doing today.
Yeah, I think my concern is that the checkpointing, the reasons or the motivations for it are really different depending on the use case, right? Like for checkpointing in service of sort of recovering a self-hosted cluster looks really different than checkpointing to maintain existing running state after a kubelet restart. So like the coasting aspect, I think, is really useful generally. The restart things that aren't currently running after a cold start, that makes me really nervous, especially when we start trying to make that apply to general pods out there. Like, I don't want a kubelet who can't talk to the API server to start trying to remount persistent volumes for some pod if it can't verify with the API server that it's still supposed to be doing that, right?
Again, that application level checkpointing or DMTCP or something of that nature is completely out of scope. And
well,
there's no intention.
Once you start letting any arbitrary pod opt into this checkpointing, I don't see how you keep it out of scope.
Well, they have to be annotated from the spec. So, I mean, the person who starts to annotate, I mean, there's going to be limited bounds of what is capable, right? And I think the clarity is just to document it as such, because I think the confusion lies in the name, as Clayton pointed out earlier, because it's not from the word checkpointing has many connotations, right? And when we say that, it can be ambiguous. But if we call it something very specific, there's no ambiguity of what we're trying to do here, right? It's only for this purpose at this time. And you could extrapolate it for some other means, and it could eventually expand in scope, but we're not going to touch that, right? That would be
so with the proposal. Yeah, what's possible to checkpoint is basically any pod that could run as a static pod that doesn't reference anything else. That's kind of that's why Tim has all over the place like limited checkpointing in the document. But yeah.
Not to be pedantic, but static pods can use config maps.
No, they can't.
Can they?
No, they can't.
They can't use secrets, but they can use config maps.
No, they can't. Static pods can only be created by nodes. Nodes can't create pods that reference resources.
So to move the ball forward here, I think the common theme we have here is that I think there's still ambiguity with regards to secrets, right? And the name checkpointing has various connotations, so I'm happy to change the name. Don't really care. I just want to move the ball forwards such that we can get a self-hosted control plane to cold start properly after it's been pivoted from a static pod. Right? So happy to change the name. I'm open to suggestions. My plan is to put the proposal out there soon, along with a whip, and talk with Yuju. Are there other major concerns that folks have? I mean, we want to provide a path forwards that is not, I think there's a lot of hearsay going on too. I think the sig-node team has said they want to expand the scope of this. I leave that to them to decide when and where and how. And I think that we will eventually have the capabilities to store not checkpoints, we'll call them something else, semi-manifests, whatever you want to call them, to persistent disks to allow for the cold start bootstrapping scenario. Are there other major contentious points that folks wanted to talk about or think that what I'm saying is absurd? I'm happy to listen to that too.
So we talk about, this is not application checkpointing, but we did consider potentially extending this to checkpoint internal kubelet states in the future. So we said that this is not a goal for 1.8, and we don't want to checkpoint any internal kubelet states. But I think it's also fair to say that it's possible if we call this checkpointing and we imply that we are checkpointing some of the things that we get from the API server, that eventually we could reuse this for some kubelet checkpoint internal states. For example, if kubelet accepts a pod or rejects a pod internally, it should persist this onto the disk so that when it restarts, it can get the same information that the decision that it made before. But we're just saying that if we do decide to call this checkpointing and do something similar, it's possible to combine both and then just store some of the pod objects on the disk and treat them similar as if they were from the API server. And I understand that there are concerns about kubelet syncing those pods, trying to get the persistent volumes while API server is down. I think we'll avoid doing that explicitly. It's just sort of a recovery phase where kubelet can see those information and access them. But if the decision eventually is to limit the scope even further so that we only write static pods, they are not checkpoints in any sense. They are a special mechanism just for self-hosting those master components, then I think this would be a completely separate issue. And yeah, we should just stop calling it checkpointing anything.
I don't think the mechanism that is there or that I've started working on would be different for scenario A versus B. It would be the semantics that people want to use and make sure that it's been vetted properly by all parties. So the general mechanism is an abstraction layer, and I could call it cats and dogs, and it wouldn't matter. What it's doing is the same thing, right? So long as we denote certain things that it does not do, I think we're okay. And we can move forwards. How sig-node wants to use this going forwards and add more value to it for their purposes, I think is another proposal on top of this. And it would be like how we are expanding this idea. That seems like a reasonable approach. It's like phase 1 and then phase 2 and then phase 3.
I'm hearing a lot of silence and no either agreement or dissenting opinions with what Tim just said. So I guess we'll start with dissenting opinions. Does anyone disagree with that statement? Okay. Does anyone feel strongly that this needs to be renamed from checkpointing for 1.8?
I would probably prefer that we come up with a clever name that is not checkpointing, just to remove this, and I'll leave that up to do that. Like, I don't know that it has to happen right away, but let's call it what it is, which is not checkpointing. It is, self-restore or static pod pivot or something clever.
I will call it clever name.
Insert clever name here is sufficient for me.
All right.
If I understand correctly, in the actual proposal, this is not really storing content from static pods. You already created those as pods in the API server, and you are trying to pick some of them to write down to the disk. So I guess I'm a little bit concerned about how general this mechanism is when you just say we can pick some of the pods and just write them as manifest onto the disk.
Yeah, I think Tim addressed that a little bit earlier, where if this is annotation and a feature gate, then anyone could put it on their own pods, but it's not likely to work the way they expect. And so if it's called checkpointing, people might see that and say, oh, I want to checkpoint my pods too. Like, I should use this for my application. and go down a bad path. And so I think that's where we need, through documentation and maybe the name of the annotation, to make it clear that like this type of feature will work for checkpointing the control plane, because the control plane is using host networking and can be run as static pods. And if you're using features that sort of don't satisfy those constraints, you can put this annotation all you want, and it's not going to do what you think it will.
Yeah, ultimately, it all comes down to documentation, right? Because can anyone tell me off the top of their head what exactly an init container does, besides the people that actually know it, have in the know, someone who's random, right? Because everything comes down to documentation at this point.
It's just as I noted, I think it's pretty easy to restrict, like on a node level as well, that if the annotation or whatever is there, but it violates the policy by just ignoring the annotation.
Yeah, I don't think we should use an annotation to control first-class behavior, but
that too. But it's, well, do we have the alpha field gating proposal ready?
We don't have to have field gating. We can use a feature gate to prevent setting a field. We've already done that several times. So until we get general mechanisms in place, we can do it off of a feature gate.
Did we have any conclusion on like pods referencing config maps generally?
Config maps and secrets are resource references from pods, and neither are allowed in mirror pods. In secrets were not ever allowed, and config maps are not allowed if you are running the node authorizer, which is by default in 1.7 in GKE, GCE, and kubeadm. The intent was for secrets and config maps to behave identically. So I mean, it makes sense, right? You only let a node get the config maps that are being used by its pods, and if you let it create a pod and say, hey, I'm using this, then any node can get any config map it wants. So.
Yeah, so the answer is then no to like checkpoint, like have this type of checkpointing for config maps.
Not by an arbitrary node, right? Like if you're the administrator and you're setting up a self-hosted cluster, then you can create those pods and mount in config maps and specify it that way.
Yeah, so I mean, if the pod references the config map and all is well, like it's authorized to do it, will we be able to like checkpoint it or not? I mean, we've talked about it for some time, but do we have any conclusion, right, how to proceed?
The way that the bootcoup checkpointer works is it rewrites the pod manifest to reference a host volume. That's how the technical implementation of checkpointing for bootcoup works, at least.
So it pulls the resources local and references them that way.
Yeah. I mean, in the kubelet, it would be nice if it was just loading them into, I don't know the kubelet code well enough to know how it actually applies this, but if it was loading the checkpointed config maps from disk and applying them to the pod normally without rewriting the host paths. But
So Tim, do you feel like there's any sort of consensus on a path forward for your proposal, or are we still at a bit of an impasse here?
I don't see, for the first phase, I don't see there being a problem. I think as long as we call out the next phases and there are separate proposals regarding those phases, I think that's a reasonable approach here. and not call it checkpointing.
What would phase 2 of this be then? I think that's well.
I think phase 2 would probably be the pivoting of the config maps, right? And then have that be a separate proposal.
Aaron, does that seem like that's a reasonable spot to draw the line? I know that sort of directly on your concerns that phase 2 will never happen and it won't be useful to you.
Yeah, I mean, I think it's reasonable that this stays pretty focused to at least start moving it forward and get some use out of it, and then we can just revisit these things.
I am still curious if is the goal that a self-hosted cluster can restart a kubelet and with all API servers down, restart as if it were running against an API server, and then use these checkpointed pods to get the cluster back running? Is that the end goal here?
It's basically to restart the API server itself, as well as the other control plane components.
Okay. I think the kubelet startup order, if you start a kubelet and tell it you are a kubelet running against an API server, it's a significant change.
Are headless. No, these are kubelets that are headless. So it's not self-hosted kubelets. The kubelets that are hosting the control plane are simply there to run static manifest pods at the beginning, right? And then they pivot, right? And during that pivot, the original static manifest pods were the control plane itself. The pivot then allows them to be hosted. So like the API server is hosted by a kubelet, but that kubelet itself has no notion of a control plane.
I think Jordan's asking about what happens during the cold start case. So you got that set up, and then you turn your master machine off. So there's only one. You restart your master machine. How does the kubelet come back up? Restart the control plane and register itself, right? Because there's a race there between the kubelet trying to register itself to see what it should run, and trying to get the API server back up and running.
I don't see how it's different than any other existing restart of the master components. How is it different?
Because it's during the kubelet initialization. I think that's what Jordan was asking. Jordan.
Yeah, this is getting out in the weeds, so we can take this afterwards. I just am I've been in the kubelet startup flow enough to know that a change that like tries to add a third type of thing, like you've got static things, you've got API things, and now you have checkpointed things also, getting in the middle of the startup flow is going to be interesting and may require violence to the startup flow.
They're mostly like static things, but yes.
But then you need to hand off and transition to the paths you get from the API server, right? I guess one question is, how do you do that on the cold start?
Yeah, this is in the weeds, so we can take it offline. I just would like to have that sketched out and clear before we kind of start trying to build the pieces of it, just to make sure that the big picture hangs together.
So that's actually one thing that we will have this problem if it is just simply a cache for the API server, because they are the same pod. Now you are starting different pods, which are pod manifest files that you read from the disk. So you have essentially two pods running at the same time with master components.
Yeah.
Yeah, so I think for the special mechanism that just for self-hosting master components, the overall transition handoff or the special case handling would actually be even more trickier.
So in terms of names and behavior, does this seem like essentially run once static pods?
I mean, that's what I had in my mind. We're either run once or kind of cold standby, like block and then run if conditions that if the control plane isn't available, then these static pods come to life either by blocking it on a container or you know, so that you get that standby behavior or a cold start behavior. That's what I had in my mind, but I didn't know. It seemed like it'd be cleaner to have like one kubelet run. Its job is to run this control plane via static pods, and these static pods have enough intelligence in them to not stomp on a control plane once it's actually running, right? And so that's all that thing does. And then separately, you have a kubelet that's a normal kubelet that talks to an API and can do its normal startup flow, and then they each have their own responsibilities. And on a cold start, the one whose job it is to establish the control plane if it's not there is working off of static pods. It can recover, but it also doesn't. It tolerates the control plane being available. I don't know. Like I said, I'm concerned about entangling like 3 different things in service of 2 really different use cases in a single kubelet and a single startup flow. But maybe I'm just overly skeptical that that'll work out. So I didn't have anything else. We can move on.
We have 5 minutes left on the clock and no other agenda items, so not sure there's anything to move on to. I did have a question about what you just said, though, Jordan. You said that you were worried about us having 2 very different use cases. What do you see that? I mean, I guess in my mind, I only see one use case here for why we want this. What do you feel like the other use case is?
Different use cases around running static pods in a kubelet. So in one case, the intent of the static pods is to bootstrap a control plane and then get out of the way. And so that's different than I have these pods that I just always want to run on the kubelet, and I have no interest in kind of migrating them, doing the set up the cluster and then pull the tablecloth out from underneath the cluster. Like that's a really specific use case, and being able to recover from that once you've pulled the tablecloth out requires a lot of fancy things that if you just want some logging solution running on every node, just running a static pod, you don't need to worry about like running the static pod and then stopping the static pod, but then letting the static pod run again if it needs to, or at the checkpointed version of the pod run again if it needs to. So those are the different use cases I was talking about.
Right. I think that's why Tim's doc is targeted not at that use case, right? This is not intended to replace run fluentd and all your nodes in a static pod to disappear after they start. It's really targeted at cold start recovery of just a control plane, right? And that's why I say I feel like there's just one use case here, and that one use case is you say you have one master node and you reboot the node. How do you get your API server running again? And the downside of permanently maintaining static pods is sort of what we have today with upgrading the static pods, is that you have to then rewrite these manifests, which is potentially becomes difficult across upgrades, especially if you want to keep static pod manifests in sync with the sort of daemon set or deployment objects or resources that you have in the API server. Right? It's much simpler. Like on an initial deployment, it gets fine, like you just create them the same. But then during an upgrade flow, if you only have to upgrade one thing, that seems a lot less prone to error than having to upgrade 2 things and keep them in sync.
Possibly. I mean, given how specialized the use case is, I had hoped that we could embed all of that complexity and logic either in the static pods or in a component that the static pods, the bootstrap process starts up. So once you have a bootstrapped cluster, you've got a manager running that is maintaining the static manifests, saying, here's, I'm at version X of my cluster, so I'm going to go make sure all of the nodes have version X of the static pod, and the static pods are going to start up and say, oh, the cluster's up, I don't need to do anything, I'm just going to block in my init container, and if the cluster goes down, I can recover from it.
Again, that sounds a lot like what CoreOS has today.
Right, and I think it's a complex enough use case and a narrow enough use case that encapsulating that in something that doesn't affect the general kubelet startup flow is appealing to me. But I like taking all of that and putting that in one place and not having it affect the general startup flow, make the general startup flow have to reason about like stitching together these three things. So I think the example of what CoreOS has done is a success story. And you know, if there are things that we could do to make that easier or better, that's great. But I like being able to layer that on top of the kubelet as it is. But maybe I'm in the minority.
I mean, Aaron had mentioned earlier that they had trouble with it from sort of a reliability standpoint of being able to detect whether that the external thing should or should not be started up. Aaron, do you want to mention anything else about that briefly?
Yeah, I mean, the main things are that like we have to essentially determine local state from the kubelet, and the way that it actually updates its internal state is that if there's no API server running, then it reads from the container runtime, determines its state, and then tries to persist it to the API. But then if it can't, then when you hit the /pods API endpoint on the kubelet, that never actually gets updated. It has to update it in the API server first before it updates that local API endpoint. So we're relying on the running pods API endpoint to actually determine the true local state. And that's actually a debug endpoint that we shouldn't be using. So it would mean if we wanted to continue doing something like this, like I've even considered just directly trying to hit the CRI endpoints to determine the local state instead. But we would need some more consistent API where we could get that true, like what is actually running state. So this is possible. It's just we've kind of like had to work around those because the end goal in our minds was that this would be put into the kubelet, not an external process. But if we wanted to go the external route, then we would need to do some work there. And shuffling files around on disk is just kind of gross. You know, we're essentially rewriting config map and secret paths to be host mounts because we have no ability to inject those at the runtime, which the kubelet would. It's just, it works, but it's not the cleanest of implementations.
Yeah, I agree it's not reliable trying to determine what's the internal state of kubelet, and then even by looking at the running pods is not really good. And but I do partially agree that if we shove this whole thing in kubelet, it's going to be very complicated. It's a very special use case. If we treat them as separate pods, then only certain pods can be used with this kind of mechanism. And also it complicates the handoff mechanism and everything.
I'll also say, like you'd say, shuffling files around on disk and rewriting pod manifests is gross, and I kind of agree, but what we're talking about is shuffling around files, checkpoint files on disk and rewriting, like faking API responses. So, I mean, it's kind of a shell game, right? Like we're acting like we have the API available when we don't really, and you can either do that by taking those resources locally and making them host mounts as you did, which I agree, it's kind of weird, but it's inspectable, and like you can look at it and say, oh, what is this doing? These files are here, it's mounting these directories. Okay, that is working with the system and it's understandable. Or you put all of that inside the kubelet and you say, well, when you start up, if you don't have the API available, but you have like a persisted list of config maps from this folder, then act like you got them from the API. Like that's kind of gross too. So I don't know, before we kind of take all this internal to the kubelet, I just want to make sure that it's serving more use cases than just this narrow one. and that we feel like we can actually maintain that complexity. I'm not confident we can, but like I said, maybe I'm in the minority.
All right. Well, unfortunately, we're out of time, so I think we're gonna have to call it here. And I think if people want to continue the discussion, obviously there's another meeting next week. And in the meantime, there are the GitHub issues that we can keep working on. So thanks everyone for coming. If you have anything to add to the meeting notes, please do so. And we'll see you guys soon.